Stats lovers, let's go over quiz number 12, 4-1 to 4-6, taken on April 19th, 2021. You pick a card at random from the following cards. Put it back, and then pick another card at random. So, how many cards are you picking? We're picking here two cards. And it kind of tells you this is the first card, and this is the second card. Well, if I want to summarize, there are 5 of these, and the probability of getting, say, red would be, how many red cards are there? 2 out of total 5. And then yellow would be 2 out of 5, and the probability of blue would be what? 1 out of 5. And remember, if you add all those up, the probability should equal 5 over 5, which is 1. Remember, probability can only be 1. Okay, so here's another question we have to answer. From the first to the second card, are the events independent? Is the second choice affected by the first choice? And the answer is it doesn't affect it, so you are independent, yes. Okay. Why is that the case? You pick a card at random from the following cards, and then you put it back. There's the key word. Put it back. Because if you, they say don't replace it, or let's just say you eat the card, that means there would only be 4 cards to choose from on the second choice, not 5. And then that way, that would not be independent. The second choice would be dependent on the first one, because you have one less card. All right, so the probability of, whoops, that's a highlighter. So probability of blue, and because they're independent, I can now multiply a probability of blue again. And that's just right here, that's 1/5, so 1/5 times 1/5, multiply across, you're going to get 1 over 25 is your answer. Now it says write in a fractional form. I hope I don't see any decimals. That's the answer for number 1. All right, question number 2. Choose the correct option. A 6-sided dice. You know this thing, you guys remember this? And it has a bunch of different numbers on it. I don't know what it looks like, but it has all the numbers, right? What is the probability of getting either a 2 or a 5? Question, how many times is this dice being rolled? Only once. Okay, it's only being rolled once, okay. What's the probability of getting a roll a 2 or roll a 5? Now, again, these do not have any intersection because there's no overlap. The sample space of getting a 2 versus a 5, there's no overlap. So, or is our addition. The probability of rolling a 2 plus the probability of rolling a 5. Well, there's a total of 6. So I've got 6. And rolling a 2, there's only 1 2, right? So I'm just going to make this super obvious, hopefully. Right, so here's 1, 2, 3. I'm creating all the sample space. All the different outcomes you can when you roll the die once. And die is singular for one of these cubes. So you can only get a 2 right there once. Or if you rolled the cube, the die, one time, you can only get a 5 once. Well, when you're adding fractions, the denominator must be the same, so you have 2 6, which is same thing as 1/3. 1/3 is your answer. That'd be choice C. All right, what do we got next? Probability number 3. 2 events, A and B, are independent. Keyword there. Probability of A is 0.3, and probability of A times B is 0.24. What's the probability of B? So remember, when the events are independent and I see the word and, what does that turn into? Multiplication. Here, these are all puzzle pieces, so we wrote this one down. Okay, let's interpret this one. That one turns into multiplication. The probability of A times the probability of B equals 0.24. Now let's use this puzzle piece. Probability of A is 0.3. Every time I see probability of A, I can write 0.3. And here you're just solving. So this problem is just a test if you knew that the word and independent means multiplication. So if I divide both sides by 0.3, this cancels. You're left with probability of B equals, put that in your calculator, you get 0.8. 0.8 is the correct answer. Number 4. In a class of 25 students, 3/5 of the class are boys, and 2/5 have blonde hair, and 1/5 of the class are boys with blonde hair. If one student is chosen at random from the class, what is the probability that the student is a boy or has blonde hair? Show your work on Scratchpad, which I'm not, you're just getting your answer. Okay. So you can choose to put this in any visual you want, right? You could have done, best one probably would be a Venn diagram. Yeah, you can do this in a couple of ways. But I want to tell you about equivalent fractions. Let's say you multiply this one by 5/5. This would give you what? 15/25 for those that are boys. And if you do the same thing over here, because I'm trying to get that 25 here in the denominator. See that? This would give you 10/25. And do the same thing over here. You'll get 5/25. So, what do they want from us? At the very end, it says the probability of a boy. What color is that? That is my green. Probability of boys is 15/25. Okay. What math operation does the or turn into? That is plus. Okay. Then it says a blonde hair. So blonde was in this blue, so 10/25. But there is some intersection here. The intersection is that there are 5 boys that have that are boys and blonde hair. So I actually have to subtract the intersection. Subtract the intersection because you're double counting. So then you just do the math operations there. 25 minus 5 would give you 20/25, which would give us 4/5 is your answer. 4/5 is your answer. Now, if you attempt to put this into a Venn diagram, and there are 15 boys, so, sorry, there are 15 boys, and remember this whole circle represents 15, but it said that the overlap is going to be 5 of them. So 5 plus 10, so this is boys. And I'm trying to give you guys a visual here. And the blonde hairs, so blonde, and there are 10 of them. So a total of 10, that means it would be, there's my visual of the Venn diagram. So if you guys can take it into a visual, super helpful. Two-way table shows the classification of students in a mathematics class by gender and dominant hand. A student who is Ambidextrous uses both hands equally well, which means you can use both left and right. Actually, I think my layups for basketball is better in my left hand, and I shoot better with my right hand from far. Part A, what is the probability that a randomly selected student in the class is female? Okay, given, keyword guys, given that the student is right-handed. So we would write this as probability of female given that they are right-handed. What does this mean? The right-handed, you're going to look at how many people are right-handed. That's the denominator. And so that would be this one right there. 23 people are right-handed. Okay, looking at just the right-handed people now, how many of those are female? Female would be 12. So I have 12 out of 23, which would be choice C. That one's a conditional probability problem. All right, B. So it looks like it's an independent problem, so different from part A. One student will be selected at random from the class. Oh, I guess you already do it too. Consider these events. Event X, so you can do something like this, probability of event X, that the student is a female, and the probability that the student is right-handed. Which statement about the events are X and Y are true? Okay, so I see the word what? Independent on all of these. Are X and Y independent? Then kind of like remember my analogy is like, you live with your parents and like Y moves out. And if someone drinks or makes a smelly, I don't know, recipe of ramen or hamburgers or some kind of soup, does that influence everyone else in the house? Well, that's the question. Well, you have to think about this. Is there any relationship between female and right-handed? Yeah, because you can be both female and right-handed, which basically means that there is an intersection of the two. So these are both saying, A is saying the events are independent because no right-handed students in the class is larger. No, that doesn't really matter. B, the events are independent because the number of categories for dominant hand is different from the number of categories for gender. No. And C, the events are not independent. Okay, I like this one. I like independent. I'm going to circle that. Because for one of the dominant hand categories, the number of females is 0. You can take a look at that one. That was not the case. That was ambidextrous, so not that one. Okay. The events are not independent because the probability of X is not equal to the probability of X given Y. That is the definition of independent to prove that. So the answer for B, part B for 5, is D. All right. This problem is just match each term in this definition and each formula to its own. So I'm going to write over here, I'm just going to use numbers 1, 2, 3, 4, and I'm going to call these A, B, C, and D. Okay, which one, probability of A or B of if events are not mutually exclusive. Not mutually exclusive. This is kind of like the boys, blonde, and then subtracting those that are both boy and blonde. That would actually be B. This formula down here. Okay, what is a complement? Remember, that's the yes plus no equals 1, and then you might have something like the no's are equal to 1 minus the probability of yeses. Okay. So what do we got here? Well, this is the only one that has the word complement. Given a set A, the complement of A denotes A prime is the set of elements that are not of A. So this notation here is A and not A equals 1. That's what it's trying to say there. So the answer for that one would be 2D. This one down here. Okay, number 3, mutually exclusive events. Two events that cannot occur simultaneously, meaning that the probability of the intersection of the two events is 0, also known as disjointed event. Yep, that's that one. Because remember we talked about in class that if there is no intersection, then that would be that one. So that would be 3C. 3 is C. And then number 4, conditional probability. Remember, conditional probability, you have this condition. Given B, so that was in the denominator, and then their intersection of both A and B. So this one is A. Okay. Number 7. Felipe surveyed students at his school. He found that 78 students own a cell phone, and 57 of those students own an MP3 player. MP3 player is like an iPod or something that plays music. There are 13 students that do not own a cell phone, but own a MP3 player. 9 students do not own either a device. A two-way table for the information is given below. Okay, so in this problem, just take your calculator and just do a bunch of subtractions. So to figure out A, I'm just going to subtract 78 minus 57, and that gives me 21, right? 57 plus 21 gives me 78. 13 plus 19 gives me 22. Going down, 21 plus 9 gives me 30, and if you add that, you would see equals 70. And 70 plus 30 gives you 100, and 78 plus 22 gives me 100. So A is 21, B is 22, C is 70, D is 30, and E is 100. So that's just filling out a two-way table. All right, Venn diagrams. Teachers at Green High School have asked students which social media site they prefer. Students in 2 classes have been surveyed. The following questions has 3 parts. First, answer part A, and then second answer part B, and then answer part C. So there's 3 parts. Mr. Smith asked his class if they used either social media A, social media B, or neither, and he compiled the results in a Venn diagram. Okay. So, part A. Use the diagram to select the answers to complete these sentences. Okay. So you have multiple choice for the second parts. I think you had a drop down. Let's see. No, you were just asked to find the number of students. Number of students here. Okay, so if you just have A, remember this one, union, or A or B. So A has how many? A has 20. So probability of A is 20. The probability of B you have 18 here, so that's the whole circle, right? So it's 12 plus 6. And then, of course, you would subtract their intersection in there. So, because you're double counting those 12 students. So that would give you 38 minus 12 would give you 26 is your answer. Okay, these are students that are what? Use either A or B or both. Double check that one. Yeah, remember we want the either. This one does not have the word and, nor is like a complement and sort of saying no, not A, not B. We want the keyword or. So that would be that choice. You can have the word either in there, but that's the selection. Okay, find a intersection. Remember that symbol we had here? Where is their intersection? The intersection is, what color did I have it in there? That's the blue, the original blue. That would be 12. Okay, what does intersection mean? Well, you are actually using both of them. So it would be this one. Let's make that clear. This one and this one. Okay, so 1 point apiece. And then part B. Part B is kind of weird, but that's how I broke it up. What is the probability of selecting a student from Mr. Smith's class at random? He uses only. That means don't use both, just social media A. Social media A. Let's just erase all this now. Okay, this is the only A, right? And how many students are there? Well, you can just add them all up. You have 20, 30. So 8 out of 30. 4 out of 15, which is choice D. Part C, if a student from Mr. Smith's class uses social media A. Okay, so I'm going to point this out. This one does not say the word given, but that's what it is. Given A. So this is your conditional probability. What is the probability that they use B? Okay, so that means probability of, or only those that are in A. So let's go back up here. How many people are only in A? Let's erase this part. This is part A, right? So given A, they only use social media A. That's how many people. A plus 12 is what? 20. Let's write that 20. Okay, now we have to look at in just A, how many are B? Well, you have, this is the only part that's part of B, so that would only be the 12. And we have a percent here, so you don't have to use a calculator, but you can. 6/10 is 60. So that would be choice A. Part C, 6C is letter choice A. Okay, Mr. Smith recorded how many students were wearing white shirts and how many were wearing non-white shirts. He put on the data into a two-way frequency table. What is the probability of that a randomly selected student will wear a non-white shirt? Okay, so we don't have any adding here. We have a total of 38. Oh, sorry, they already added it for us. So you can do that two ways. You can add up the boys that are wearing the non-shirts, right? So we're trying to count up the non-white shirts, so that's 8 over 28 plus the girls. they're not wearing non-white shirts. And that will give us 19 out of 28. Because that's the non-white. So that would be choice D. Now, you can do that through the complement, right? So, I don't know what to call that. This is the complement. So, white shirts plus non-white shirts equals 1, right? And white shirts are 9 out of 28. And let's just say you just want to solve for non-whites, but we can just calculate it. But 1 turns into 28 over 28, right? Make this over 1, and then you multiply numerator and denominator by 28. And if you subtract 9 over 28, and if you subtract 28 minus 9, you will get non-whites to equal 19. So 2 ways of figuring out that problem. Hopefully that was helpful for you guys. See ya. Bye-bye.